All right, well, welcome back. We're now going to take a look at that next exercise, network mapping, and we're still going to be using those same virtual machines. This picks up for us on page 44 within the workbook. And if you look over here, you'll see that I have actually not made any changes to the system since we were last together. So I'm just going to log back into this one, which should be about the same condition that yours were in too at the conclusion of the last lab. Now, the point of this lab is just to get you to use Nmap a little bit and to introduce a tool or two that can be used to make your life a little bit easier in dealing with these, with managing network maps. Let's see here. So in page 44, it's first of all making sure that we have our virtual machines up and running, which we find there in step 1, and we are already have done that. We also have the username and password for the auditor VM documented there. And next, it says that we'd like to start up some services. So starting services, in order to make the scan results more interesting, we're going to add a couple of things in. So to do that, it's talking about using this auditor virtual machine. I'm going to begin by just clearing the screen, and I'm looking at the directions that it's giving us. In the directions, it's suggesting that you use the sudo command with the service command to start a variety of services. And those commands will work as written within the lab. However, during the last lab, you may remember we had a little blow up with hping with certain parameters. So as a result, we had used sudo su to actually become the root user. So since I currently am looking at that pound sign, I am a root user, I'm just going to run the service commands directly. And let's see here. So we're going to start up the send mail server. It says it's already running. And we're going to start up the Apache 2 service. So this is just giving us some things that we can actually find when we run a network scan. Finally, it asks us to start up the SSH service. Again, it indicates that it's already running. Now, it next says that we should get a terminal window running, though of course we've already done that. So I think it might be a little bit out of order here. Sorry about that. And it then wants us to get started using Nmap. And it has some questions we'd like to answer. And the questions involve looking at the manual page for Nmap. The very first question that's asked there on page 46 is, how do you run or perform an IP protocol scan? The purpose of this little section of the lab is, well, to introduce some useful features of Nmap, but also to get you to start using the manual page a little bit. It turns out that many of these tools there's only a few options that people are generally familiar with, when in fact there are many options that are extremely useful, but a little bit less known. An example of that would be what we talked about in class, where we had loose source routing. That's something that's built into things like FTP and Telnet and Ping, but people just aren't aware of it because they never read the manual page for it. So similarly, we're trying to force you to do a little reading here. Though, to be frank, we don't have the time in our recording to read through the manual page. Well, I'm not even sure we have the time to skim through it, which we could just page through. But still, there's so much to find, that's going to take us a long time. So I'm going to cheat a little bit. One of the things that you can do within a Unix manual page is use the / character. And you can see that when I type that in, the slash shows up with a cursor flashing next to it. It's waiting for me to type some text. So I'm going to try protocol. And when I do that, it's going to search down and find locations where that word shows up. So I see here, let's see. So the first one, port number and protocol, service name state, not what I'm looking for. But the next one, when an IP protocol scan is requested, -S capital O. That sounds like what I'd like. So I'm going to go back to the top here, and I'm going to search for S capital O. Now I find that one, the one I just had, but I'm going to hit the letter N. Look at that. So right there in the quick help is the IP protocol scan. Let me hit the letter N again to see if there's another one. Here it is. So now it shows me the details of what that protocol scan actually does. And you can read through those paragraphs yourself. Well, we found the answer. The S capital O, it'll let us do a protocol scan to find what protocols are available on a particular network stack. Let's see what that might look like. We'll run Nmap. I'm going to add in the -n option so it doesn't try to do that hostname resolution. And we'll do the -S capital O against my own machine, 127.0.0.1. It comes back and says, very interesting. It turns out that this machine supports more than the protocols I would have just expected. I would have expected that it supports ICMP and TCP and UDP, but it also supports IGMP, or multicast. And it additionally supports, Protocol 103. I'm not particularly familiar with that, but it says it's PIM, and it supports 136, some protocol known as UDP Lite, and some other protocol, number 255. Now that's actually quite unusual, because if we were to go out and do some research at IANA, the Internet Assigned Numbers Authority, we would find that all of the protocol numbers are defined by IANA. And the last I looked, I believe that they only went as high as 138. So that's really an unusual protocol, and one that doesn't have an assigned name yet, even from IANA. So the protocol scan shows us what kinds of protocols, not services, but what protocols my network stack understands, and in particular, what IP protocols. If it supported NetBUI, well, that's not going to show up here. That's an entirely different network protocol. These are just the IP protocols that are supported. Now, that actually answers a question that we have there on page 46 and asked us to run that kind of scan and see what showed up. But there was another question that I skipped over. It also asked us to determine how to do version scanning. So let's do Nmap, man Nmap. Let's try the word version, and we'll do our same trick. So I see version, 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 but none of these look like a particular scan type. Let's go next. Not a particular scan type. Oh, let's see here. A typical Nmap scan, I'm looking at that second full paragraph, is shown in example 1. The only Nmap arguments used in this example are -A to enable OS and version detection. Well, that sounds like what I'd like. But it looks in that case like it's not just version scanning. It looks like it's also doing OS scanning. But I do see that it tends to do this version scanning. It calls it something called version detection. So let me quit out of this, rerun my manual, and search for version detection, and let's see what I find now. Service version detection. Oh, -S capital V. Probe open ports and determine service and version information, and then we can even modify that, how it's going to do it. Now that's interesting. Lots of people, it turns out, know about the -S capital V, but did you know about the -- version all to try all possible scans or probe types to determine what the version is? And again, we can get more information by searching for the S capital V and then finding the section that talks about it. In this case, not giving us a lot more detail there, but I can see just below it version intensity, version might, versions all, version trace, so I can get more information that way. Now, when does that apply? Well, a version scan is not going to apply when you do a protocol scan, because a protocol scan, that's not talking to services, and the version scan is designed around services. So on page 47, it asks us to run another scan with, I'll again add my -n, -S capital V, against the localhost machine. So that's doing the version scanning. That means it's going to take the standard port numbers that Nmap will use for a scan, see whether or not those ports are open, and if they are, it will do what we see here. It will additionally try to identify what version of that protocol is actually installed there. And the way it's doing that is by nudging the port. Now, that's actually the simplest one. For instance, when it goes to the send mail port or to port 80, it's going to nudge the port and see what it comes back with, see if it sends a banner back. And that would be particularly true with the send mail port. However, on port 80, just hitting enter is not going to get you that. it's actually going to require a valid request. So one of the probe types is to send an HTTP request and see if it gets back a web answer. And inside of that, you will often find version information for the server. Or with OpenSSH, it's actually probing to see whether or not SSH is there and retrieving version information from it. So it's actually a very, very clever and very useful system. We can now answer the question that's listed there on page 47. What ports are open on the host and which services are being used? Well, we can see what they are, and two of them are actually duplicates. 25 and 587 appear to be the same service. One of them is likely there being used to be designed for SSL communication, because 587 is typically the SSL or SMTP over TLS or SSL port, so that's likely what we're seeing there. All right, excellent. Now, it does give us the tip at this point saying that if we add the -TN, that's going to eliminate the DNS lookup, but we already learned that trick ourselves, so we're okay there. The next part, though, there on page 47, is starting to try to make this data a little bit more useful, because the problem we have is that creating an Nmap scan of a single host, well, that's easy to manage, but scanning on a whole network, how do I manage the results? There could be tens of thousands of hosts in there. So to that end, in the directory of the auditor user, you can see that there's a file over there named Audit, actually a directory. So if I simply go into that directory, and let's see what's in the directory, there is a file called nmapdata.txt. And if we look at what's inside of it, we can see that there are some Nmap results. Now, these Nmap results were produced using the -O option. If you look at the manual page, you'll find that that allows you to create what's called greppable output. Greppable because it allows you to search for a term, and it's going to include all of the data that it retrieves on any particular host right on a single line, which means that if you can match a term using grep, you'll see all of the details for that host. How could we use that? Well, I'll tell you what. Let's do a search. I'm going to grep for SSH in that Nmap data file. And I can now see hosts 1, 12, 13, 22, 23, 24, 25. All of these hosts appear to have SSH open. So it really is as easy as that. We simply have to tell it what we'd like to look for. In our particular case, we were looking at port 22, and we can see that it was open, but it is possible, depending on how the scan was run, that you may actually find 22/closed/TCP. So simply searching for SSH may not be enough, or may not be specific enough. Instead, we might prefer to do our scan like this, especially now that we see what the format looks like. Let me search for 22/open, and I'll search for that in my Nmap data. There we go. So now, even if there were closed port 22s being listed, those would no longer show up in my grep output. And that's what's being demonstrated there on page 48, getting us to look and find and see if we can find out how many have some things open. Now, that was for port 22. The next one says, how would you obtain a listing for hosts that have port 80 open? Well, it's really just as easy as that. Let's change this over to 80, and instantly we switch to 80/open. Let me change this just a little bit. Now, I haven't pre-screened this data, so it may not be that there's a result, and in fact there isn't. I checked to see whether or not port 53 was open. And the reason I had that one in my mind is that we may want to refine this even more. Port 53, as you know, is used for DNS, and DNS typically is listed on port 53 UDP. What if you wanted to distinguish between UDP and TCP ports that were open? Well, that's what I was driving at. So let's go back to this 80 open. You might also want to refine that and say, but I'm really looking for the TCP ports. Similarly, with the port 53, I may want to say, yes, but I want to know the TCP or the UDP versions that are running. So we can further qualify it. So it allows us to be very, very specific in finding out what's going on. Now, Before I move on, there actually was another question it had there about those port 80 hosts. It asks how many hosts were running port 80. Now, we could run the test, we could run the grep, and we could count these, but you know, it's going to be easy to lose count here, isn't it? You know what might be easier? Let's leverage part of what Unix does for us. It turns out that there are some really powerful text processing utilities built into Unix. Now, we'll talk more about that when we do our Day 5 material, but here I've added the pipe symbol that says send this output through something. I'm going to send it through this command called WC. That stands for word count. What word count will report to you is 3 values. The first number, 18 in this case, is the number of lines that appear in the output. The next number, 204, is the number of words that appear, and the final number, 2344, is the number of characters that appear. Our question had been, how many hosts are listening? My answer is, well, the number of lines. And in this case, the number of lines is 18. Far easier than trying to count these manually. And trust me, there is a problem much later in class where you will be confronted with a question something like this, not involving a file named Nmap data, but somewhere that you're probably going to need to use grep and some other commands and then count how many things match. And if you try to count it by hand, I've tried to do it, you will get a different answer every single time you count. Much, much better to use something like word count. You can even do fancier things using word count, but again, we'll come back to that a little bit later in the week. Now, it says here that if you identified the right command and it ran successfully, you should have received 18 hosts, which is exactly what we got. That's going to take us to part 2 of this section on network scanning. It has to do with using this PBNJ tool. So I'm moving on to page 49. I'm going to clear my screen, just so I have a nice clean place to work with. And it starts out by asking me to do a scan. The scan it's asking me to do is kind of interesting. It's asking me to do an Nmap scan against the local network, but it's asking me to add in some other options. Particularly, it's asking for this option here. Now, if you look in the manual page, you would be able to find that that command means output the Nmap output in XML format. Now, this is actually quite similar to what we were just working with, because that was a greppable format file. That was created with the -O capital G. This O capital X lets me specify XML. So it asks me to store it in a file called localnet.xml. There's nothing special about that name. It's just the name that was selected for the exercise. And to do version scanning and OS fingerprinting. Now you may remember that there's another way we could do those two things with a single option. Do you remember what it was? We ran across it when we were searching through the manual looking for the version scanning. It was the capital A. So I'm going to cheat. I'm going to go a little bit different than the book and say, well, there's another way I could do that same thing. And it then asks us to run the scan against 127.0.0.1 through 10. Now I'll let that get started. And as I run it, you can see that there are answers that come back, but you might say, well, where did all those hosts come from? And the answer is, all of those hosts are your host. They are the auditor virtual machine, which means that they'll all be identical. That's not ideal for the lab, but it does illustrate and allow us to create some data very, very quickly. So we could scan this against as many local host machines as we wanted. In fact, let's do that. I'll change it to 100, no problem. So your machine will actually answer every single one of those. You could make it even bigger if you needed to. So if I wanted to simulate a much larger network, your host will actually answer all of those addresses because the 127 network is actually a Class A address. If we look at the network mask on the adapter for it, you'll see that it's an 8-bit network mask. In other words, 127.0.0.0. So the broadcast address, or the network mask, would be 255.0.0.0, the whole thing. That's why it will answer all of these questions. Now, I might have You know, it's like when you go to a diner, my eyes might have been bigger than my stomach because it's actually taking a little bit longer to run than I'd like. So I'm going to stop it and see, do we have some data there? We sure do. Let's see what we could do with that. It turns out that we have this handy tool called Scan PBNJ installed on the system. Scan PBNJ can be used to directly run scans against hosts, but it can also be used to import XML copies of scans. To do that, we would simply run scan PBNJ-X. That's the option to tell it to import an XML file. We can see it up there in the top in target specification. So I'll tell it to look at localnet.xml. Off it goes. And it comes back and says, oh, yeah, all right. So it's giving me an error because I terminated the scan. So I'll tell you what I'm going to do. Let me come back and run the scan again. And I'm just going to have it run through subnets 1 through 2. There we go. So we'll have about 200 hosts. And there's the scan PBNJ, inserting hosts. So what it just did is it parsed through that XML file, and it has now added all of those hosts into a SQLite database. Now, SQLite is just what's used by default. It turns out that you can configure this to talk to MySQL or Postgres, or if you wanted to do a little tinkering, you could get it to talk to an Oracle server, a Microsoft SQL server, any kind of SQL server, because it doesn't use anything weird. It's all very, very standard SQL. And once it's in this format, once it's in the database, we can now query that for any kind of result. And that's what it's talking about there on page 50. On page 50, it's showing you the file called query.yaml. This is a file that comes with the PBNJ tool and has all of the built-in scans or queries that it's able to run. Now you can look through that yourself. You can see that each line is actually the definition of a name of a type of report, and then the SQL statement that lets that happen. So if you know a little bit of SQL, you could tinker with these or add your own, or you could even get a database administrator to help you, because the schema for this is extremely similar. That allows you to turn this into a very powerful tool. But for now, let's take a look down on page 52, moving into page 53, because there we're start taking a look at the output PBNJ tool. So it's like this. But a really important option that we have here is the --list option that'll show you all of the different types of queries that it can actually run. So the one that we were looking for is the monthly report option, and I can actually see that's right down on the bottom. So using that would simply be a matter of doing output PBNJ-Q monthly report. As easy as that. But this tool, the way we're using it now, requires you to manually run Nmap yourself and then import the results. Is there an easier way? Well, the answer is yes. Instead of doing it manually, we can actually have PBNJ run the scan itself. If we run scan PBNJ against a target, 127.0.0.1, it actually performs the Nmap scan against that host using standard options, the ones that are explained in the class in the slide there, or in the manual page for PBNJ. And we can also override those options and specify our own specific scans that we'd like to run. When we run it in this case, it shows us that it's inserting that host. It also gave me some pointers here that we could use the -- system or specify other DNS servers this way. We didn't have a DNS server, so that's why that took a little while. But let's see if it can detect a change. What we'll do is follow directions there on 53. Let's do service SSH stop. So SSH has now been turned off, and let's run that scan again. And hopefully, it's now going to realize an adjustment has been made, because this host already exists within its built database. There we are. So now we can see that there's data showing up there. We can also do some other things. Let's do the output PBNJ-Q monthly report. And now, oh, that host now does show up within the monthly report as a host that had a port that had been turned on. So it can be a really handy tool for figuring out and managing results over time. I'm a big fan of an additional tool called the YANDiff, yet another NDiff tool. And there's even more in the lab here that's getting you to do some other adjustments. For instance, let's just do it. It's also asking us to start open the OpenVAS D, there we go, and the ampersand here means put it in the background, so you can see it's off doing its thing, it's loading its plugins. While it's doing that, I can actually, well, no, I actually probably have to wait for it to finish, so that'll take it a few seconds. But I can read ahead a little bit. Looking ahead in the workbook there on page 54, we can also override how the scan is run. And you can see that happening down toward the bottom of that page. That's the -A option, so that we can manually specify which options we'd like sent to Nmap and override things that are done as the default. Because by default, it's not going to scan all ports. But for a network inventory, I'd really want all of the ports always being inventoried. So we would probably add that in ourselves. In fact, well, no, I don't want to run ahead. Let's let this finish what it's doing. It'll only take it a few more seconds. The OpenVAS is a vulnerability scanning engine, and we're actually going to use that in the final exercise that we have for today. So we're going to want to get that running anyway, which is why I let it go. All right, all plugins loaded, so it's ready to go now. So now let's redo this. Let's do a scan PBNJ of 127.0.0.1. Off it goes. And then we're going to run it again, but this time with override options. We're going to tell it to scan for all ports. And then we'll ask to see the latest output, which is what that very last thing is asking us to do there on page 54. That way we can see what changes. So it tells us here, machine is already in existence. It says checking current. Okay, there it is. So scan complete. No changes. Notice nothing in green, nothing in red. Let's run it again. Let's do the scan PBNJ with the -A option, and we'll tell it to do the very verbose with OS fingerprinting and version fingerprinting, also known as A, and we'll scan for all ports, and I'm going to add the -N in as well, and we'll point it at 127.0.0.1. Inserting machine. Wow, that was much, much faster. Let's do the output PBNJ -Q latest change. Latest change is that SSH went down. We now see the machine show up. That was pretty easy. I'm going to go back and just take a look at this again. I didn't like how fast that ran. It does seem like it should have been a little longer. Let it do the DNS. No, it still seems to be okay. Let's do the latest change again. All right, so that's the latest change to it. The reason that I'm a little bit puzzled is I'm thinking that we should be seeing OpenVAS listening. Now, let me just take a quick look here. I see port 9390, I see 587, I see 631. So I'm wondering why I'm not seeing those in my report here. So let's take a look at Nmap. Actually, we can go right back here. Let's just do a little test here. Let's do an Nmap with these options. And there we go. All ports unfiltered. Very interesting. Why is it not actually giving me the results, though? Oh, apparently I have forgotten what the -A means. I thought it also told it to do full version fingerprinting, so I must have something a little bit wrong there. Let me go back and rerun that scan PBNJ, and I'll put in the right options. And you know, I'm just thinking the problem could be another issue too. Let me check one thing. Nmap-V. Nmap-version. Oh, there it is, 520. So the version of Nmap here is a little older than I thought it was. So in a newer version of Nmap, you can actually use the SA. In this older version, you cannot use that. So that's why the directions in the lab must be telling us to do it that way. So sorry for leading you astray there. Let me go back and do this the right way then. -SV-O-N. All right, that looks right. So this will take a little bit longer. It was a little too fast before. Apparently it was simply doing a ping sweep. Perhaps in the older version that indicated to do all ping tests. Let this run. All right, now I see that other services have been added in. Excellent, that's what I should have been seeing. And now if we do an output PBNJ-Q latest change, it tells me that's what changed most recently. These new services are running. Perfect, exactly what we were looking for. All right, so sorry for misleading you there, but I always prefer to do these labs with no rehearsal, because that way, if I run into problems, you actually get to see me work through the problems, and hopefully they're problems that you might run into too, or maybe they'll save you from having trouble in the future. For now, though, we're through with this lab as well, so we're going to stop this recording, and the last recording we'll have for the day is going to be the vulnerability scanning.